Assalamu alaikum dear students. Today the topic is permutations and combinations. So let's start with the question. Hannah chooses 5 singers from 15 applicants to appear in a concert. She lists the 5 singers in order in which they will perform. How many different lists can Hannah make? So here order matters. So this could be the permutation. So number of lists, you can simply say the number of lists she can make is 15 P3. Grab your calculator and get the calculation, that is 360. So we are done with part A. So in part B, of the 15 applicants, 10 are female and 5 are male. So the condition is find the number of lists in which the first performer is male, the second is female, the third is male, the fourth is female, and the fifth is male. So we are going to make a box according to the condition given by the examiner. Look, this is first, second, third, fourth, and fifth. So there are 5 males. The first should be male, then female, then male, female, and then male. So there are 5 males and 10 females. Remaining males are 4, remaining females are 9, and remaining males are 3. So number of lists will be 5 P1 multiplied by 10 P1 multiplied by 4 P1 multiplied by 9 P1 and finally 3 P1. If you get the calculation, then you can say कि 5P1 is 5 times 10P1 is 10. Grab your calculator and get the calculation. So 4P1 is 4 and 9P1 is 9 and 3P1 is this. So if you get calculation from the calculator, the answer will be 5400 are the lists that can be number of lists of different performers according to the condition. So moving to the next part. Here, Hannah's friend Amy would like the group of 5 performers, including the more males and the females. So here is another condition, but the order in which they perform is no longer relevant. So order does not matter. So it means it is no more permutations now. It has become combination. So we can say if I have male and there are 5 males and then I have female over here and then I have my selections. So the first scenario of the 5 team could be like if I choose 3 males, 2 females. Second could be if I choose 4 males and 1 female and 5 female and 0 males. So if I use the combinations formula, that is 5C3 into 10C2, use your calculator, you will be getting 450, and 5C4 10C1 50, and final is 5C 5 and 10C0. So that would be 1. So we can say the final answer would be look 450 plus 50 plus 1 will be equal to 501. Moving to the next question. Two of the applicants are Mr. and Mrs. Blake. Find the number of different selections that include Mr. and Mrs. Blake and also fulfill Amy's requirement as well. So Mr. and Mrs. Blake are there. Mr. and Mrs. Blake, they are there in the selection, and then males and then females. So there are two, then there are two Mr. and Mrs. Blake, and then we need to make the team of 5. Then the two are present, then you can take 3 males and 0 female. So your selections would be like 2C2 times 4C2 times 9C1, that is 54, and then plus the second one would be 2C2 times 4C3 and times 9C0. So it would be 4 when you add these two terms, so 58 will be your answers. The next part, a bag contains 10 pink balloons, 9 yellow balloons, 12 green balloons, and 9 white balloons. 7 balloons are selected at random without replacement. Look, without replacement, find the probability that exactly 3 of them are green. So total number of selections, so you can simply say total number of selections are 40, C7. Number of selections with 3 greens, that would be green. There are 12 green, so it would be 12C3 times the remaining are 28C4. There must be 7. So the probability, find the probability selection contains Exactly 3. Greens. So finally I can say it's 12C3 times 28C4 over 40C7, and use your calculator, and the answer is 0.2416. I hope you are getting the hang of the question. So move to the next one. A plate of cakes holds 12 different cakes. Find the number of the ways these cakes can be shared between Alex and James if each receives an odd number of cakes. So according to the condition, here one is Mr. Alex and other one is James. And here would be the selections. So if Alex contain 1, James would be containing 11. If it is containing 3, other would be 9. It's containing 5, other would be 7. If it is 7, it would be 5. If it is 9, it would be 3. If it is 11, it is 1. So now we are going to make the selections. 1 out of 12, that can be written as 12C1 times 11C11. That would be the answer. And the next one, 3 are selected for Alex, so 12C3 times 9C1. Here we are getting the next one. And then 12C5 times 7C7, and then 12C7 times 5C5, then 12C9, 3C3, and finally you can say it's 12C11 times 1C1. Here we are getting our answers. Grab your calculator and get the selections. So it will give you 12. This combination will give you 220. The other is giving you 792. Again 792, then 220, and then 12. If you add all these combinations, then you will be getting your answer like it would be 2048. That's your final answer. So moving to the next part, another plate holds 7 cupcakes, each with a different color icing, and 4 brownies, each of different size. Find the number of different ways these 11 cakes can be arranged in a row if no brownie is next to another brownie. This is very important. There are 7 cakes. So write the cakes first. Look, I'm making the spaces for cakes. Cake 1, then cake 2, then cake 3, then cake 4, cake 5, cake 6, and cake 7. Make another spaces. You need to find the number of different ways these 11 cakes can be arranged in a row if no brownies is next to another brownie. So look, So the number of different ways. 7 cupcakes means 7 factorial. And 4 brownies. So the spaces are 1, 2, 3, 4, 5, 6, 7, and 8. So it would be 8 permutate 4 brownies. So 7 factorial into 8p4. Grab your calculator and get the answer, that is 8467200. So these are the number of different ways you can arrange those 4 brownies among these 7 cupcakes. The third part of the question is, a plate of biscuits hold 4 identical chocolate biscuits, 4 identical chocolate biscuits, 6 identical shortbread biscuits, and 2 identical gingerbread biscuits. These biscuits are all placed in a row. Find how many different arrangements are possible if the chocolate biscuits are all kept together. So look, chocolate biscuits are kept together. So first keep the chocolate biscuits together. 1, 2, 3, 4. The 4 biscuits, and they are identical. So its arrangement be 4 factorial over 4 factorial, that is one way. And if I group, this is one group, actually this is one group. These biscuits are all placed in a row. Find how many different arrangements are possible. So you can say one group plus 6 shortbread plus 2 gingerbreads. So total are 9, like group 6 gingerbreads and 6 shortbreads and 2 gingerbreads. 6 plus 2, 8, and 1, 9. So it would be 9 factorial over 6 are repeated. It is 6 factorial and 2 are the ginger one, the 2 factorial. So it will give you, grab your calculator and get the answer, that is 252 ways. This is one group. 4 identical chocolates are placed together. If the chocolate biscuits are all kept together, so this will be the way in which you can arrange them. So after this question we have another question, that is, a selection of 3-letter words from the 8-letter word collider is made. How many different selections of 3 letters can be made if there is exactly one L? If there is exactly one L, look, number of selections, say number of selections with one L. 1, 2, 3, 4, 5, 6, 7, 8. So you need to 1 L, exactly 1 L. So you can choose 2 words. 1 L has been selected, and then 6, C2. You can select 2 letters out of 6, and then 3-letter word will be made. So the final answer is 15. Moving to the next one. How many different selections of three letters? There are no restrictions. When there are no restrictions, then you can make words like, look, the first, no L. If there is no restriction, then no L selected. I'm not selecting any word of L. It's no selected. Select any three words out of 6 words. So it would be 6, 3, 3. You cannot select any L. So no L is selected. 6C3, which is giving you 20. This is first scenario. For the second one, 1 L is selected. There are no restrictions, so you can do what you want. In first selection, no L is selected. In second, 1 L is selected. So if 1 L is selected, then you can choose another 2 words. If 1 is selected, so it means you can choose 2 other words out of 6. So 6C2 would be 15. And the third option would be when 2 L's selected. When 2 L's are already selected, now you can select only 1 word out of 6. So it would be 6. So total number of selections, total number of selections would be 20 plus 15 plus 6, giving you 41. So it was very easy question. How many different selections of 3 letters can be made if there are no restrictions? When there are no restrictions, you have your own choices to make a word of 3 letters. In first, no L selected, so it means you can select other 3 words out of 6. So the answer will be 20. If you select 1 L, then you can select 2 words out of the 6. It will give you 15. But if you select 2 L's, then you can select 1 word out of the 6 words. The selection will be 6. So the final answer is 41 ways or 41 selections. The question number 5. The digit 1, 3, 5, 6, 6 it can be arranged to form many different 7 digits numbers. How many of the 7 digit numbers have all the even digits together and all the odd digits together? So first, we can make a group of even digits. It's very simple. If I am making the even digits group, that could be 6, 6, 6 and 8. So I can arrange it 4 factorial over 3 are repeated. That would be 3 factorial. So the answer is 4. Now I can make odd digits. So how many odd digits can be? They can be 1, 3 and 5. They are odd. If they are odd, so their arrangement could be just 3 factorial. There is no repetition, so 3 factorial is 6. The groups can be, so this is first group, this is one object, this is second object, so they can be arranged alternative by 2 ways. So the groups, you can say we have 2 groups, so groups can be arranged by 2 factorial. and that is 2. So the final answer would be 4 factorial over 3 factorial multiplied by 3 factorial into 2 factorial, and final answer is 48 ways. So that is our final answer. How many of the 7 digits numbers are even? Look, how many of the 7 digits are even? If I make my box technique, so you can write the numbers 1, 2, 3, 4, 5, 6 and 7 digit number. So are the even. If I place 6 over there, if 6 is there, so I can place 8, then 6, then 6, 5, 3 and 1. This could be the 1 and this is 1. So 6 factorial over 2 factorial. The answer would be 360. This is first way I can arrange. The numbers are even. My second way would be like this. If I place my number 8 over here, then 6, 6, 6, 5, 3 and 1. So this would be my selections. So it is again arranged 6 factorial over 3 factorial into 1. That would be 120. So my final answer, total number of selections would be 360 plus 120. The answer is 480. So this is the answer. We can arrange how many of the 7 digit numbers are even, and the digits 1, 3, 5, 6, 6, 8 can be arranged to form many different 7 digits numbers. So dear students, moving to the next one. Find the number of different arrangements that can be made of all 9 letters in the word cameraman in each of the following. There are no restrictions. When there are no restrictions, so you can write the word cameraman. So there are 9 letters, so it would be 9 factorial over 3 repeated. A comes at 3 times, so A comes at 3 times, and M 2 times, so it would be like 3 factorial into 2 factorial, that is 30, 240. According to the second condition, the A's occupy the first, fifth and ninth position. So if you make the positions like this, so we have first position, this is first position, and here it is A, and at the last position there is also A, and 1, 2, 1, 2, 3 and then A. So there will be the arrangements like 6 factorial over 2 factorial. Six factorial over 2 factorial, the answer is 360. Coming to the next part, there is exactly one letter between the m's. So if I place my m over here and then space and then I place m, so I can repeat this process. So this would be actually 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it could be like 7 times 7 factorial over 3 factorial. So use your calculator. It would give you 5880. But you can show the working as well. So this is the first way. In second way, you can make your grid or block like this. So now leave the first place and then place m, then leave the place and then write m, and then leave all the space empty, and then make another working like in third case, leave the 2 places empty. Now place your m, then leave the place and put your m. This would be your third. And in the same way, you have to make your 7 arrangements, and that would be the final answer. The fourth part of the question is the word cameraman. Find the number of different selections if 3 letters include exactly one M and exactly one A. If it is M and it is A, so this is the one and this is also the one. So 3 letters. If M and A are selected, so you can select only 1 out of 4. That would be your 4 answer. The last part of the question says, find the number of different selections if the 3 letters include at least one M. So one M is selected. Look, at least one M is included. So it means now he has to select 2 letters out of 4. So 4C2 would be 6. Then I can make another. No A's are selected. You can make the conditions. No A's. No A's are selected. So M is already selected. You can again select 2 words. So it will give you (4C2), 1M and no A's. So this is 6, the same thing, 4C2. But in the third situation, you can say in position 3, 1A is selected. If 1A is selected, then and M is already selected, then you can say it is 4C1. The answer would be 4. And the third condition, if 2 M's are selected, if you select 2 M's, then one letter should be selected, 4C1. It would be 4 as well. If 1A is selected, then you can select one other word. So 2 M's and 1A, so it would be 1. So final selections could be 6 plus 4 plus 1 plus 4 and plus 1. So the final answer would be 16. That's it for today.